yeah, in this video we will learn about the AutoSAR. We will see like what are the features of it, what are the layers of an AutoSAR, what is an application layer, what is the service layer, what is the BSW, what is the routine, what is the mode management, what is the diagnostics management, memory management services like COM service, LIN service, Ethernet service, what is the PDU routers, all those things we can see in this video. And before starting, I think most of you guys may come from the non-automotive background where the AutoSAR term is quietly famous for, I mean, new for you guys. So nothing to worry. I'll just cover your stuff as well. So uh, yeah, before starting that, I'll just tell you what is the reason or idea behind developing the AutoSAR. Just think like you are developing a project where let's say you are developing a body control model, and in that you are using the Infineon controller, and for communication you are using some NXP 1463 ASICs, and you are using BTD6020 as an I said driver for it's off from the Infineon. So what happens is today you have developed the software for this mentioned hardwares, and you have given your product to the vendor, and everything is running smooth. But after we don't know how things will go in future, right? So after 2 to 3 years, your ASIC manufacturer say that I have to stop this product because nobody is buying it. So I'll be, since the ASIC developer said that, so we have to change the software also, because we have developed our software in such a way that it is highly coupled with the hardware. If since there is a change in the hardware, then we'll have to change the entire software development life cycle as well. So that case, what happens is, you must be invested much time in the developing the software, and you have put too much R&D cost. You might have put too much time in that. So all the entire procedure should be redone it, because the below guy is changing his hardware, so we don't have any other options also, because if there is no availability of a hardware, then there is no meaning of developing keeping the software ready, which is completely tightly coupled with an existing hardware. So to avoid that, these tier 1 suppliers like Bosch, Conti, ZF, and the tier 1 OEMs like Benz, Daimler, and some other guys have came up with an idea saying that we will build the software in such a way that we will make it in a layer by layer. So if there is a change in the below layer, which is completely dependent on the hardware, if that layer is getting changed, and then in that case there should not be any effect on the topmost layer, so we could save our least time. you know uh, in the earlier case, what happening is your entire software architecture is being changed, but if you use an AutoSAR, your below layer is getting changed, but the other two layers are being reused, right? So something is better than nothing. I mean, before you guys had to change everything, but now you got option. Okay, I'll keep the application layer and the RT stagnant, and I'll just have to change the base software layer. So it could be easier, right? So that is the idea behind this, and yeah, we will not waste much time in the introduction itself, so because there is too much things to learn in the few minutes. Okay, let's start. Okay, yeah, okay. AutoSAR is an automotive open system architecture. Okay, this is an AutoSAR. It mainly has three layers. One is application software layer, second one is runtime environment, and third one is base software. Okay, now what is an ASW? It's an application software layer. It's a topmost layer, and it basically deals with the software components. So this application 1, application 2, 3, 4 till n, these are the software components. So what are software components here is, let's say you're talking about the ADAS vehicle L1, L2, L3, L4. So these guys has to be a completely automated one. If I talk about it should be completely automated one. There should not be any manual work. So this guy could contain n number of software components like braking software components. There is airbag software component. There is communication software component. There is door lock unlock software component. There is hatchback software component. So these are the software components which needs the data from the below layers. Let's say now I want to apply a brake. Okay, what I'll do is I'll call the brake software components, and with the block these guys, all the guys will be having some respective block IDs. So I mean they are nothing but a standard APIs which got the different IDs. So this guy will call the brake API, and this API will go through the RT, and from RT it will reach to the base software layer. In the base software layer, which it will be, this guy will basically deal with the actual hardware. So that guy will see the condition, and it will revert to the RT. From RT will revert to the ASW, and it will see the response. If it see its expected response, then it will apply the brake. If it doesn't see the expected response, it will not apply the brake. So the main work or the behavior of the application software is to be a stagnant, should not worry about the below layers, should not worry about the below hardware, just request the standard APIs and get the respected data back. That is the main behavior or function of an application software. Now RT, the second layer is runtime environment. RT, it's just a middleware. It will facilitate the communication between ASW to the BSW. Let's say consider this, there is no existence of this guy. Then this guy should talk in the air and this guy should listen from the air. So that's impractical, right? We cannot, things doesn't work like that. So it's most important guy because he's only facilitating the communication between two different individuals who got two different work culture, work ways. So we should not forget this guy as well. And the third one is base software. So this is the main guy. This guy is again has the service layer, again has the ECU abstraction layer, and third one is MCAL, microcontroller abstraction layer. So these layers are more important when it comes to the AutoSAR. So the MCAL guy is the guy who is completely dealing with the processor, is completely dealing with the COM stack, he's completely dealing with the hardware. So if there is a change in the hardware, yes, definitely this guy should be changed, and the other guy should remain stagnant, because since this guy is completely dealing with the hardware, he has regular interaction with the hardware. So this guy should be changed. There is no other option. So in the 100% work, you are changing the 30% and 70% you are keeping the stagnant. Then it's good, right? Something is better than nothing again. Yeah. So that is the main working of this MCAL. And this is this complete block is the BSW. This is a service block. In the service block, there are OS management, mode management. What does the mode management will do is it will check it. Let's say you are starting the vehicle and you are turning on the ignition. So it will just allow the only respective software components. So while turning on the ignition, I don't want to read any. I don't want to have any communication. So it will stop the com stack and it will disable it and it will save the power. And during the ignition, I don't want to run any NVMs, any memory management things. Then it will basically it will turn on only the respective required things. And what does the diagnostics layer will do is, let's say you must be heard in recent years that if something happens to your car, you directly go take it to the showroom. In this showroom they will read the DTCs, diagnostics trouble code. In the DTC it will be mentioned that what is the reason the car has been failed, why the battery went dead. So all those things could be stored in the diagnostics layer. And the third one is memory management layer. So this guy will abstract the hardware and it guy doesn't worry that where my code is being stored. Is it being stored in the flash or is it being stored in the EEPROM? It doesn't worry which non-volatile memory it's being stored. What is the work or function of this guy is to store the when you are stopping the vehicle, it should store the condition of the vehicle, and During runtime, it should read the real time data like speed and all. The other one is service layer, communication service layer, and it got PDUR. So again, PDUR is nothing but, let's say the upper guy is requesting some data to the below guy. So PDUR, what it will do is, it's a protocol data unit. It will assign, it will make the data frame in the form of packets, and it will route back to the below layers. Likewise, the abstract microcontroller abstraction layer will deal with the hardware, and again this guy will be abstracted from the hardware. So the functions of each block we will see in the next coming video. For this video, we'll wrap up with this much only, because hence even I'm tired. Yeah, we'll wrap up.